Hello, my name is Roger, and I'm doing a remake, my explanation of a C10 and up planet gear carrier assembly. These are the gears and components in the rear of the tractor. You may know what this is. This is known as the pinion shaft. It transfers power from the back of the tractor to the forward reverse and the PTO. This pinion shaft fits right in the planet carrier like that. When the planet carrier plate turns, it turns the pinion shaft. Now we have to learn what causes the plate to turn. This is the front ring gear. This gear works low gear in the tractor. The planet carrier fits like so. It can orbit inside like so. We'll learn more about that later. One important thing to note is that the forward orbit gears fit completely inside this ring gear. The rear orbit gears, the high gears, fit the rear ring gear. Kind of like, let's see. So, a clutch cup and the clutch sliding pins fit right in between. We can even try that. The last part you see on the table is the gear cup or rear spacer. The clutch cup would be there. This rear ring gear would be like so. Clutch cup like so. If I put all these parts in the model, we wouldn't see the action of the gears very easily. So what I'm going to start with is just these two components driving the pinion shaft. My model has a mock Kohler drive shaft with a double gears on it. Let's see what happens. I forgot to show you my model Kohler crankshaft. These are the two gears that are pushed onto the crankshaft. The tip of the crankshaft fits into the bushing in the center of the planet carrier assembly. Okay, to repeat myself, we're starting the demo with only the forward gear cone. The rear gear cone or high gear cone is off so that we can see better what's happening inside. The handle turns the two engine drive gears. We can see the bigger gear. The smaller gear is out of sight. The bigger gear drives the smaller orbits. The smaller gear inside drives the orbits in the ring gear. I'm going to pretend to be the clutch cup and hold this ring gear. And you can see, hopefully, those orbits inside the ring gear. They are being turned by the engine crankshaft gears. They are turning, but they are pinned to the planet carrier assembly, and they are forced to turn and orbit inside the locked ring gear. Now I'm going to put on the rear ring gear and we'll take a look at output of the model. Okay, now I have both ring gears in place on the planet carrier assembly. I have my one up on my fancy degree wheel. My handle is up. First I will shift the tractor into low gear and lock the forward ring gear. Let's see what happens on our output. One turn of the handle, a little better than 1/4 turn of the output, excuse me. 2 turns, a little better than half. 3 turns, a little better than 3/4. 4 turns, a little better than 1. Our gear ratio with the low locked and the larger of the orbit gears working is 4, a little better than 4 turns of the engine to 1 turn of the crankshaft. Now we'll reset our fancy degree wheel and I'll try to hold the rear ring gear or high gear. 1 turn, a little better than 1/4. 2 turns, almost 3/4. 3 turns, a little better than 1. That gear ratio would be a little better than 3-to-1. So we had a 4-to-1, little better, and a 3-to-1, little better. One other thing, well, we have the model here and assembled. We know that if we shift into neutral, the pinion shaft shouldn't turn. That's kind of hard with a Planetary assembly and a clutch cup. But let's see what happens to the ring gears when we shift into neutral. They both turn, but they don't do anything. And that was supposed to be neutral.